All right, today we're diving into a type of software that is way, way more than just a number cruncher. We're talking about tools that actually understand the language of mathematics, tools that can tackle problems that would make a regular calculator just, well, give up.
I mean, have you ever been in the middle of a tough problem and just wished your calculator could handle variables? You know, that it could work with X and Y just as easily as it does 2 plus 2? Well, you're in luck because that tool is very, very real. And it's called a computer algebra system, or CAS for short. Honestly, the best way to think about it is like the ultimate upgrade for your calculator. It's a genuine assistant for when the math gets serious.
So what exactly is a computer algebra system? It's a program that's built to handle math not just with numbers, but symbolically. And that one word right there, symbolically, that is the absolute key to everything. It's where all the magic happens.
Here's the fundamental difference, right? Your calculator sees the symbol for pi and gives you an approximation, maybe 3.14159. But a CAS, it understands that pi is this perfect, infinite idea. It works with the actual symbols, which keeps the math completely pure and precise.
So, who are the big names out there in the CAS world? Well, the whole field is really dominated by a few major systems, and each one has its own cool history and its own set of strengths.
On the commercial side, you've got these heavy hitters like Mathematica, which has been famous for its notebook interface since way back in 1988. Then there's Maple, another giant that's been a huge favorite in universities since the 80s. And for anyone looking for a free, open-source option, there's Maxima, which, get this, has a lineage that stretches all the way back to the 1960s. How cool is that?
Okay, so to really get a feel for how a CAS works, let's zoom in and take a closer look at one of the most powerful systems out there, Mathematica. So how do you even get your hands on it? You've got a couple of really great options. For long-term use, there are student licenses you can buy. But if you just want to dip your toes in and see what all the fuss is about, you can sign up for a free 15-day trial. What's awesome is that the trial also gives you access to Mathematica Online. This lets you run the whole full-powered system right in your web browser. No installation needed. It makes it incredibly easy to just jump right in and get started.
All right, let's fire it up and see how this thing actually works. We're going to start by just using the notebook as a kind of super-powered calculator.
But first, the single most important tip for anyone who's just starting. To make a command run, you don't just hit Enter. That just moves you to a new line. You have to press Shift and Enter at the same time. Trust me on this. Remembering that one little thing will save you so much confusion.
Okay, let's try a super simple addition. You type in 2 plus 3 and then hit Shift-Enter. See that? Mathematica automatically labels your command as input 1 and then gives you output 1, which is, 5. It keeps this nice, neat, numbered log of everything you do.
Multiplication is just as easy. You can use the little asterisk symbol, or you can even just put a space between the numbers. The syntax is really flexible and pretty intuitive.
And here is where a CAS just leaves a normal calculator in the dust. You want to know what 3 to the power of 100 is? There it is. The exact result instantly. No scientific notation, no rounding anything off, just pure, precise math.
Now here's another really key detail you have to get right. Brackets. They matter a lot. Parentheses, the round ones, are for grouping terms, just like a normal algebra. But square brackets, those are only used for functions. And then you've got curly brackets, which are for creating lists. That's how you'll define things like vectors and matrices. Getting this right is totally crucial.
Let's see that incredible precision in action again. Mathematica knows about important constants like pi, which you'll notice is capitalized. If we want to see its numerical value, we use the function n. So here, we're literally asking for pi calculated out to 100 decimal places.
And there you go. That is a level of precision you can just call up on demand. This is so far beyond simple calculation. This is what true symbolic computation is all about. Okay, so now let's move past basic arithmetic, because the real power of a CAS isn't just in the numbers, it's in handling algebra. Now, watch this. We can assign the value 17 to a variable, we'll call it a. Then we can use a in a totally new expression with another variable, b, that we haven't even defined yet. Mathematica just instantly plugs in the value, simplifies all the arithmetic, and gives us the final expression in terms of b. It is seamlessly blending numbers and symbols. It's doing real algebra. And it handles more advanced things like linear algebra with total ease. You define matrices as lists of lists, using those curly brackets we talked about. And then you can do operations like addition or, as you see here with the period, matrix multiplication, and you get the result just like that.
One last really important tip. Once you're done with your variables, it is great practice to use the clear function. This just removes any values you assigned, so a goes back to being a symbol again. This is great for preventing any accidental mix-ups in your next calculation.
And you know, what we've seen so far is truly just the tip of the iceberg. A full-featured CAS can simplify and factor huge expressions. It can do calculus for you, taking derivatives, computing integrals. It can solve systems of equations and even tackle differential equations. It's an absolute powerhouse for pretty much any field of math.
We've just had a little glimpse into a world where mathematical computation isn't limited by our calculators, but really just by our own curiosity. So, I guess the only question left is, with a tool this powerful at your fingertips, what problems are you going to solve?